Let's have a look at question 8 in this video. So what if the weekly incomes of the salespeople are not normally distributed? We're going to use a sign test to test the hypothesis that there is a difference between the starting salaries for men and women. The p-value for this test is going to be 0.07, true or false. So let's recall that. What's the sign test? Under the null hypothesis, if we have no differences between the salaries, we expect to have a similar ratio, an equivalent ratio of 50% positive differences, so 50% positive differences, and 50% negative differences. So they should be spread equally. And under the alternative, in this test, we're having that the salaries for men, we expect to be higher than those for women. Let's see if that's true or false. Because this is a sign test, we're looking only at the differences, only at the signs of the differences, not at the magnitude, not at the number. So we're going to go to the table and count those differences. We go over here, just a second, like that, and we start counting. Male minus female, so the salaries, the difference between the male salary and the female. 500, that's a positive difference, minus 100, negative difference. 600 is a positive difference, that's a 0, we're going to eliminate it from our sample. 900 is a positive difference, minus 200, negative difference, positive, 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 positive. Now let's count what we just have. We have 1, 2 negative differences, 1 0 out, so we're going to have a sample of 9 observations, and out of those we have 2 negatives and 7 positives. So 2 negative differences and 7 positive differences. Let me crop this data because we'll need it. Let me do it like that. So we have hop, copy, and paste it below at our question over here somewhere, like that. Now, because we're having 7 positive differences, what we're looking for is this. This is how the p-value sounds. So the probability that we have at least 7 positive differences by chance out of a sample of 9 observations, where we have a proportion under the null hypothesis of 50% positive differences. That sounded really good. I hope you can follow and it makes sense. So the probability that we're gonna have at least 7 positive differences out of our sample of 9 observations, and the proportion of 0.5 under the null hypothesis. Now, why do we look at it as at least 7 positive differences? Because we are most likely gonna have positive differences since they dominate the count. They are more than negative differences. So we want to know what's the probability of having those and even more than those by chance. What's the p-value of that? Which is going to be the probability equivalently of having at most 2 negative differences. Since the negative differences are not that common, we expect them to be at most 2. So what is the probability of having at most 2, meaning 2 or less, out of this sample of 9 and the proportion of 0.5 under the null hypothesis? And if you follow the distribution, we're going to have the same set of probabilities. Here we're going to have values for 7, 8, 9. Here we're going to have values for 0, 1, 2. It's going to be the same numbers, like I'm going to write them right now. That's equal to 0. I'm looking at the table right now. That's going to be equal to 0.073, so 0.0703 plus 0.0176 plus 0.0020. If we add them up, that's going to be equal to 0.0899, which is approximately 0.09. So what we can see, the answer to this question is going to be false. It's not 0.0703. They only took one probability, you see. They only took this one, but we should add all of it. Because the question is not what's the probability of having exactly 7 positive differences, it's what the probability of having at least 7 positive differences. That's why we have to account for the probability of having 8 positive differences and 9 as well. So the way we read this is that the probability of having at least 7 positive differences by chance is going to be 9%, and that's above our significance level. Our significance level is usually 5%. Let's just give the conclusion for our own practice. Our significance level is going to be 5%. That's above 5%. So we cannot reject the hypothesis. We do not have enough evidence that the salaries differ between the groups. Like, although we have this trend of having 7 positive differences, because the sample size is so small, 7 positive differences out of 9 observations is not enough evidence that they differ significantly in the entire population. So that's why we would not reject the null hypothesis. And the p-value for this would be 0.09. Again, that is because it's one-sided test. If it would be two-sided, multiply that by 2. Hope this helps, and we're done.